how are your landings doing? There is no mystery in leaving smooth air flight and softly landing on a hard piece of ground after a few bumps of the landing gear wheels. Nevertheless, doing it within a restricted flight path and limited airspeed might require some skill. This video will show you some important approach and landing facts that will enhance your ability to make an air-to-ground transition as smooth as it should be. At first, let's follow a complete approach and landing procedure. Afterwards, we are going to assess some particularities governing the procedure. For a normal landing procedure, the landing configuration, gear down and flaps extended, should be established early. Airspeed, thrust, and rate of descent should be stabilized early. Make sure that the airplane is properly trimmed during the approach. This maximizes elevator authority for the flare, or in the event of a missed approach. Target approach speed is VAPP, which is VREF plus wind correction. VAPP should be reduced so that VREF is attained upon crossing the threshold. As the airplane approaches the touchdown point, reduce the rate of descent and slowly reduce thrust levers to idle so that they are idle when the airplane touches down. Normally, a 2 to 3 degree pitch change will be enough for the flare. Plan to touch down as close as possible to the 1,000 foot point. Do not allow the airplane to float in ground effect, which unnecessarily increases the landing distance. Smoothly ease the nose wheel onto the runway. After the main wheel touches down, use auto brake or apply manual braking as required for the runway condition and length available. Pull the thrust levers to reverse and verify spoilers actuation. Auto brake will be disarmed by gradually pressing brake pedals. Quite easy. You can smoothly land on a fine day on a long, dry runway. But even under demanding circumstances, you can make it easy too, once you have trained enough and know how your airplane performs, and you are really concentrated on what is going on. Let's discuss now the particularities of the operation. No approach should be initiated unless the prevailing conditions have been understood and the crew found that landing is acceptable without undue risk. Philosophically, all approaches should be treated as approaches followed by missed approaches, and landing should be treated as the alternate procedure. This mindset depends on a good approach briefing, and the knowledge of the missed approach procedure, and on proper programming of the FMS. The aircraft must be fully stabilized by 1,000 feet from touchdown under IMC conditions, and by 500 feet under VMC conditions. A stable approach is a contributing factor to a successful flare and touchdown. Unstable approaches may result in difficult landings with unexpected sink rates, side loads, or bounce backs. An approach is considered stabilized when all of the following criteria are met. The aircraft is on the correct flight path. Only small changes in heading and pitch are required to maintain the correct flight path. The aircraft is in the correct approach speed. The aircraft is in the correct landing configuration. Sink rate is no greater than 1,000 feet per minute. If an approach requires a sink rate greater than 1,000 feet per minute, a special briefing should be conducted. Power setting is appropriate for the aircraft configuration. All briefings and checklists have been conducted. An airspeed deviation is considered significant if it is 10 knots above target approach speed. Indicated airspeed may not be less than the VREF or VAPP. A significant vertical speed deviation occurs when it is greater than 1,000 feet per minute, precision, or 1,500 feet per minute, non-precision, when below 1,000 feet above ground level. If the stabilized approach parameters are not met before reaching the stabilized approach height, a go-around should be initiated. As an airmanship principle, principle, the aircraft should be fully trimmed at all times during any approach. This is especially true when it comes to aircraft where the longitudinal trim is based on change of the stabilizer incidence, because in these cases a mistrimmed aircraft is also an aircraft with reduced primary longitudinal control, as opposed to aircraft with trim tabs, where the mistrimmed condition means higher control forces only. Directional trim is especially important on one-engine and operative approaches. It is pretty easy to figure out if the aircraft is properly trimmed in yaw, if it has swept-back wings. If an aircraft is mistrimmed in yaw, assuming that the pilot is not pressing one pedal more than the other, it will require aileron inputs to remain level. So the yoke banked to one side is an indication that the aircraft needs directional trimming. To correct it, make sure that symmetrical thrust is set. Check fuel and balance, and trim the rudder to stop any turning tendency. The airplane is properly trimmed when the control wheel is neutral. On one engine in operative, it may be desirable to center the rudder trim to assist direction control during thrust reduction. Centering the rudder trim prior to landing, normally prior to 500 feet above ground level, remove most of the rudder pedal pressure when the operating engine thrust is retarded to idle at touchdown. However, be prepared to counteract rudder pedal forces should a go-around be necessary. Generally, with reduced thrust and slower airspeed, less lift on the wings and less downward force on the horizontal stabilizer is produced, resulting in a significant nose-down tendency. The elevator is automatically trimmed to compensate this tendency, according to the logic embedded on the autopilot. Be prepared to reset this landing trimming condition when the landing is rejected or if a go-around is initiated. The target approach speed, VAPP, is equal to VREF plus 1/2 steady headwind component plus gust increment. VREF is the stall speed multiplied by a safety factor considering the flapping use and is the speed at which the airplane should overfly the runway threshold. Actually, VAPP is an increase to VREF to compensate for the eventual drop in wind intensity near the ground and sudden unexpected changes in wind direction. Maximum and minimum wind additives for either normal or abnormal configurations are prescribed in Embraer publications and Company Operations Manual. The landing field length limited weight, as shown on the landing analysis, is the maximum weight at which the airplane is capable of landing in 60% of the available dry runway length, crossing the 50 feet high threshold at VREF. That is, the dry runway required is the actual landing distance multiplied by 1.67, 1 divided by 0.60. However, if the runway is wet, the minimum length required is the dry runway required increased by 15% as illustrated. Performance regulations require some corrections in the reported wind for publication of the landing distance charts. The AFM charts are developed considering only 50% of the reported headwind and 150% of the reported tailwind. In addition, the reported wind must be corrected for the aircraft's actual height. That is, a mathematical formula is used to apply a specific wind model to the last 50 foot above ground level travel. The good news is that all these adjustments are already incorporated in the AFM charts, and no additional corrections need to be made when dispatching the plane. The corrections applied to VREF have an important consequence when landing an aircraft. To really reproduce the performance published in the AFM, the threshold must be flown at a height of 50 feet and VREF. If a technique different from this is used, there will be an inconsistency between the resulting performance and the published performance. What if you dispatch a plane assuming no wind on arrival, and once you get there, the control tells you will be facing a 10 or 20 knot headwind gust? If the crew judges it safe to reduce VREF shortly before crossing the threshold, the VREF is used and the AFM performance is matched. If the crew decides that the wind correction must be carried all the way to touchdown, there are two possibilities. Go somewhere else, or there is definitely enough runway to carry this extra speed and with no overrun risks. Runway distance for overspeed landings can be reviewed at the Embraer's analysis software and properly checked against actual runway data. Sometimes the aircraft enters final while still at high speed, either because ATC vectored the aircraft this way or because the crew did not properly manage the aircraft's speed, and the deceleration towards the target approach and reference speeds requires the full length of the approach all the way to the runway. This scenario is riskier than normal and should be avoided. Once you get closer to the threshold, do not proceed with a landing if you are high and or fast. Don't hesitate. Go around at once. The landing flare should be initiated at approximately 30 feet radio altitude. Only a 2 to 3 degree attitude change is required to reduce the rate of descent. Reduce thrust slowly so that upon touchdown, idle is reached. Good flare thrust coordination is essential. Do not extend the flare with idle thrust as it will significantly increase landing distance and the resulting high pitch may lead to a tail strike. Reducing to idle before the flare will also require an increase in pitch. Flaring high and reducing the power to off quickly can cause the plane to settle abruptly. Particularly when one engine is inoperative, keep the power on and don't let a high sink rate develop. Do not apply stabilizer trim during the flare. A proper touchdown point is more important than a smooth, greased landing. A very soft touchdown is not essential, nor even desired, particularly if the runway is wet. When a light bounce occurs, maintain or re-establish a normal landing attitude. Increasing pitch can lead to a tail strike. Beware of the increased landing distance and use power as required to soften the second touchdown. When a more severe bounce occurs, initiate a go-around. Do not attempt to land. Press the go-around button and advance the thrust levers to take off go-around. Hold the flare attitude until the engines spool up and reset stabilizer trim. Then follow normal go-around procedures. Once airborne, the configuration should be changed to take off as soon as a safe height and a safe speed are reached. Initiating a late go-around after approaching may lead to a tail strike. Remember that both pitch and thrust are required for rotating. So if the engines are still spooling up, when the pilot vigorously pulls the nose up, the thrust may not yet be adequate to support the effort. The tail goes down very rapidly and tail strike can occur before a change to the flight path is made. The preferred crosswind landing technique is to apply drift correction to track the runway heading, either visually or following flight path vector commands. During the flare, align the aircraft with the runway centerline, preventing drift by applying into-wind aileron and opposite rudder. After touchdown, immediately start flying the nose wheel smoothly onto the runway. Control the airplane pitch rate while relaxing after column pressure. Nose should not be lowered rapidly in an effort to improve landing performance. This technique provides minimum lift and fully places the airplane's weight on the main gear, thus resulting in increased braking effectiveness. It is more effective than aerodynamic dragging when the nose wheel is held off the runway. Use rotor pedals for directional control. Steering hand wheels should only be used at taxi speeds. Use proper braking techniques to cope with the short landing distance. The airplane should be stopped within the shortest possible distance consistent with safety. If the landing weight is limited by runway length, The use of maximum brake effort is mandatory until it becomes obvious that there is enough remaining runway for the use of milder braking. Reverse thrust is more effective at high aircraft speeds. Hence, to get its best value, it should be used right after touchdown. It should be used judiciously so as to avoid control difficulties caused by asymmetrical thrust. Avoid use of thrust reverser below 60 knots to avoid the possibility of FOD ingestion. Apply the brakes with no delay after the main landing gear wheels have touched down, while easing the nose wheel onto the runway. This may require increased aft column control pressure to slow the derotation rate, mainly when heavy brake application is needed. Move directly to a single firm and steady brake application and hold pedal pressure until decelerated to taxi speed. Apply pressure up to a maximum comfortable deceleration. Do not pump the brakes. The recommended braking techniques should be aimed at reducing the number of brake application and optimizing carbon brake temperature. To increase carbon brake life, brakes should be operated hot, not at intermediate temperatures. For landing on short runways, full reverse and brakes should be used simultaneously to stop the airplane. During taxiing in, do not fall back to the old technique of brake pumping. Let the airplane accelerate to a maximum safe speed. Then use the brakes in one increasingly firm application to slow the airplane. Less frequent use of the brakes with higher braking pressure improves brake life. Pitch attitude awareness is essential during landing so as to avoid aft fuselage contact. Usually, tail strike is caused by unstabilized approach, holding off in the flare to achieve an extremely smooth landing, mishandling of crosswinds or over-rotation during go-around, turbulence or wind shear, and bouncing at landing. Most of the time, more than one cause is involved. Check the approximate nose-up attitude that will lead to a tail strike for each of the E-jets. The non-flying pilot should monitor attitude during flare and call out if this angle approaches. Some of the keys to avoid tail strike have been said in this video. Always perform stabilized approach. Arrive on the flare on the approach path with a fair speed and attitude. This will prevent you from applying large corrections in the flare. Handle crosswind landings by exercising active control of the sink rate. Do not over-rotate at go-arounds. Make it smooth and timely, rotating to the go-around FD command bars as gentle as the condition requires. The safe pilot is the individual that knows how to combine aviation knowledge with skills and experience. Good judgment adds extra proficiency. Practice the stabilized approach concept and accept nothing else than the proper approach speed and flight path. If it is not right, do not hesitate to go around. Set it up again. Stick yourself to this discipline and run to a perfect landing. Then park the aircraft under the applause of your passengers and the admiration of your colleagues.